Here's an example problem. You can see it's a problem out of a book of using static equilibrium to solve a problem. Remember that we're using the sum of the forces add up to be 0 and the sum of the torques add up to be 0. So what we're focusing on here is this boom. It's just a big rod, big pipe, whatever you want to call it. It's this thing right here. So this is what's in equilibrium. It has a weight of 3,000 newtons. So that weight of 3,000 newtons would go right in the center. And so this would be L over 2 because it's uniform. And again, let's not panic that we don't know the length of the boom, because we must not need to know it if we don't know it. There's also this 2,000 Newton weight at the end. That's going to produce a force on it. I'm going to call this one T1. This is going to be equal to 2,000 newtons because this thing is in equilibrium. And so if we did a really quick T1 and 2,000, T1 would be equal to 2,000. So we should be able to see it, but if you apply forces to that weight right there that's hanging, you could find that tension in that supporting cable, and it's going to be 2,000. And then finally we have, well, not finally, because I have two more things to do. I have the tension in this cable, and then finally there's support at A. So this is like a hinge. It's going to produce a force in the Y direction and a force in the X direction. That's what that support is doing. So the boom is in there at a hinge, and so the hinge is going to keep the boom from moving in the vertical direction and the horizontal direction, and that's why we have those two forces. Okay, let's look at forces in the X direction. They have to add up to be 0. In the X direction of AX and minus T2. So AX is equal to T2. I don't know what T2 is, so that's all the more I can do right now. In the Y direction, they add up to be 0. I have AY minus the weight of the boom, which is 3,000 newtons, minus T1, which is 2,000 newtons, and I think that's it. So AY has to be 5,000 newtons. So I found that. And then finally, I'm going to do the sum of the torques add up to be 0. Remember, I get to choose a pivot point to find those moments or those torques. I am going to choose here because that will eliminate AX and AY from the equation. So the first moment torque that I come to is that due to the weight of the boom, it's going to cause a clockwise rotation, so it's negative. It's 3,000 is the force. The distance is L over 2. And the angle between the two is 45 degrees. Then I go further up and I have T1. So that's also going to cause a clockwise rotation. So T1 times L is the distance, and the angle is a sine of 45. Now, T2 is producing a counterclockwise torque, so it's positive. It's a distance of L, and the angle is 45 degrees, and these all have to add up to be 0. Now, I actually can cancel a bunch of common terms. As promised, it doesn't matter what L is because it's in every term, and I get rid of it. And I can also get rid of this sine of 45 because it's in every term. So what I'm left with is minus 3,000 over 2 minus T1 plus T2 equals 0. T2 is equal to T1 plus 1,500. And T1 was 2,000, so that's 3,500. So I have found the forces on the boom due to the wire. So I found T2 and I found T1, and then I need to find AX and AY. I just found T2, and that's equal to AX, so this is 3,500 newtons. The last thing they want to know is basically they're asking if you found the resultant of AY and AX, would it be along the boom, which basically means would the resultant of AY and AX be at a 45-degree angle? So let's figure out what the angle is. It's inverse tangent of AY over AX. Inverse tangent of AY is 5,000 over 3,500. I can tell you right now it's not 45 degrees, or else they'd be the same. And it actually is at an angle of 55 degrees. So does the force at A act along the boom? No. The answer is no, because it's at 55 degrees. All right, so basically, again, you're identifying forces. You do sum of forces in the X and the Y are 0. And then the new thing is the sum of the torques is 0. Remember, choose your pivot point wisely to eliminate unknowns and make your problem easier to solve.